Yes.
Okay. Homework on pages 174, chapter 3.
Page 174.
Yeah. Cause it's like x minus -3 equals -4 plus 4. -1
Which
plus
number are you talking about?
1.
Number 1? Okay. Okay, so I got a question on page 175, section 3.2. Number 1, it says x minus 3 equals -1 plus 4. So, what's something up there you could do right away? I mean, that...
-3.
well, careful. What's -1 plus 4?
-3.
Which one's bigger?
3 or 4.
Which one's bigger between those two
4.
numbers? 4. And what's the 4? Is it positive or negative?
Positive.
So the answer should be...
-5.
No. I liked when you said 3, but I didn't like when you said negative. The
Because
big one's
positive
positive, so the answer should be positive.
+3.
Good. And on this side, it's still this.
Positive 3, -3. So that'd be
So how do you make the x get by itself?
3 negative, like 3 plus -3 equals -3.
3 plus -3 would be
1, 0.
0. And so that's exactly why you want to add 3 to both sides. Because then you get the x by itself.
Equals x equals 3.
3 plus 3?
6.
6.
Not 1 plus 4. What does the 1 plus 4 means?
That became 3, right?
Yeah.
That's all you did. Replace -1 plus 4 with a more concise name. -1 plus 4 and 3 are the same thing. But which number would I rather write? 3. I don't want to go around writing -1 plus 4. Let me just write 3, because that's what it is. So we replace that with what it is.
So can we put an x minus 3, like -3, and then put like a 3, and then we put like a line, be like...
Exactly like this is a really good way to do it.
And then
It shows you got rid of that, so you have x by itself equals, and then 3 plus 3 is 6. That's exactly how you solve equations. Try to get that variable by itself.
so just match the first one, right?
Try to get that variable by itself. Yeah.
So adding -3 plus -3 won't equal -6 or equal +3? Is that what you're doing?
All right, let's see. So let's go back. So the very first thing I do is each side, I say, what can I do on each side? On this side, there's no like terms, right? There's an x, there's a number, they don't go together. On this side, I got two numbers, so I could do that. -1 plus 4, 3. And then, now do you see, so your first step is to treat the equals as making it two separate problems. You say, what can I simplify on that side, and what can I simplify on that side? So that's your first step is, let me simplify both sides as much as I can. And the minute you're done, you got nothing else you can do on each side, you start saying, okay, why is my variable not by itself? What's in the wrong place? I want variables on one side, numbers on the other side. So who's in the wrong place?
-3.
Yeah, because here's my variables, and my numbers are supposed to be over there.
Right.
So how do I kill -3?
You add
I add 3. So that goes away. So on this side I have x. 6. Cool. I like it.
perfect.
Keep those Johns to yourself. Yeah.
Okay, and the same one, but it's number like 800 equals 15y plus 5y equals 20.
Yeah, that's true. 15 and 5 is 20. So again, see how this always works. You actually, what you do is, on each side, you distribute. On neither of these problems were there any distribution parts, right? There's no parentheses. If I distribute, then I attack each side and I say, what can I do on each side? So That's 100. I can't do anything there. But what can I do over there? You just
Five.
said it.
3, 20,
20. 20 what?
20y.
20y. Cool.
15 times 5.
So I've done everything I can on each side by themselves. Now I start to say, why is my variable not by itself?
Divided by 5.
No, you're thinking ahead. What do I divide it by? What do I not want here? What do I not want here? 20. So you're going to divide by?
5. 20 times 100.
You're going to divide by what you don't want. Divide by 20. Why do I not want the 20? Because I know I want to get the letter by itself. Right?
31.
I think you're thinking ahead. Because what's 100 divided by 20?
5.
Done. 5 is y.
But how you show your work on that?
That is the work. So you put your like terms together. Then you show me that you divide by 20. 100 divided by 20 is 5. Done.
Okay.
Yeah. So normally when you're doing equations, I'm not going to make you show all the work like the long division or whatever. You guys with me? That's where I'll let you go ahead and use your calculator, because there I'm just grading you on, do you know how to solve an equation? I'm not grading you on, do you know what 100 divided by 20 is? Right? You should. But if you use your calculator on that, I'm not going to know. I'm going to have other problems that you can't use your calculator on. Right? Equations, I normally let you use your calculator because I just want to make sure you know how to solve an equation.
And then number 13. Negative 3x. Negative 3x equals 50 negative 2.
Yeah. All right. So I think this will be the last one on this page.
Sorry.
But that's okay. I don't want to do too many of these.
Okay.
I know.
So 1. So negative 3.
Then what can you do on that side?
You don't do nothing.
You sure?
That's like negative 3.
With negative 3x's minus 3x's makes how many?
1.
No.
9.
If I owe you $3 and I owe somebody else $3?
No.
Yeah, negative 3 minus 3. They're both the same sign, so you add
Negative 6.
negative 6. So it's negative 6x.
X.
So negative 3x's, and I take more x's away, now I'm deeper in the hole. Now I owe somebody 6x's. And what's 50 minus 2?
48.
48. Okay.
By 6.
Now guys, I noticed this last time, and real quick. It's really simple for your brain to say this. Guys, you see that negative 6 and you think somehow you're supposed to involve a plus 6. But what's the operation here? Multiplication. What is multiplying by the x?
Negative 6.
Negative 6. So how do I get rid of that negative 6?
8.
Dividing by negative 6.
And you're thinking ahead again. You've got to show me.
Because 6 times 8 is 48.
I know, but that's exactly what I don't want to see. I don't want to see any guess and check. Randy, stay with it. You should be able to see a lot of these. You should be able to just go, it's 8. But I want you to get used to the steps. So when you get a problem that you can't just see it, you'll at least know the steps. And you can trust the steps, because you know it's supposed to come out to some kind of 8. So if it doesn't come out to some kind of 8 when you use the algebra, you come back at me and say, Jeff, your algebra's crap.
No, wait. Or you can, or you can do like 6 and then put a comma, then put 6 for the comma. Then like,
No. Okay. So I want my x by itself. I know that's when I'm done. So I want to get rid of the negative 6. The operation right now is multiplication. So what's the opposite of multiplication?
Add.
It's the opposite of multiplication. Divide. So if I want to get rid of this, I divide by negative 6. So now it's gone. What's 48 divided by negative 6?
8.
Negative 8. Why is it negative?
Because negative.
Yeah, there's no other negative to kill that one. So it's still there. Right?
Why is negative?
Okay.
48 divided by 6 is 8. Because 6 times 8 is 48. 48 divided by negative 6
It's negative
has to
8.
be negative 8 for 2 reasons. That negative is still there because there's no other negative to kill it. And also negative 6 times negative 8 makes positive 48. Right? You guys see that? Okay, cool.
Awesome.
So anything else from homework? Yeah. Say again? Oh. Stop. Let's see. Wait a minute, what? Oh, this is... Okay. Okay, go ahead. Oh, that's right. Okay. Yeah, real quick. I was trying to figure out. I know you all work together. Oh, yeah. You do it. According to what I said. My codes and stuff just repeated. There were some places where minus signs became equal signs. And normally tells me that it's just for every be careful. You gotta work together so everything. Oh yeah. You'll get it back as I get it ready. I gave one now.
Jeff, what is late for turn on homework? I understand about late.
Alright. So guys, I have a question about general homework policy. When is the homework late? After the test.
So like the first test or the second?
So after the test, that homework is a part of. So that last test went up to section 2.5, right? So if you have anything up to section 2.5 that you have not turned in yet, it is getting later and later. Right? Hell yeah. The longer you wait, the more late it is, and that's worse and worse. Read your syllabus. Ask me the question.
So if I do chapter 3 and I turn it in, will that be late? Could we not chapter?
We haven't been tested on chapter 3. So as long as you give it to me by the day of the test for that, you're okay.
So we are allowed to go up.
All right, guys. Hey. Yeah. Way before the test? Okay, that's not good. Most of the time I get those graded by the day of the review, so, alright, I'll look for it. I got a big stack of ungraded stuff, so I'm just going to grade it as I can. Alright, so I do my best to get the homework back to you that you turn in before the review day, by the review day, so you have it to review for the test. If I don't give something back to you that you turn in before the review day, let me know immediately, right? Because I want you to have that back so you can study. If there is... No. And tonight is a very strange night. See?
I have these parties around the waist.
You're good. You have your names on it? Yep. All right. Whew. So, guys, any other questions from homework?
Can you ask a question?
Oh, yeah, we're going to do that in a minute. Yeah. Okay. So, if there's no other questions from homework, I want to focus on that handout I gave out last time and look at those problems. And then we're going to go into the blue book and look at some stuff in there related to word problems. We'll do that later.
You want another? I got like hundreds of them. You want one?
I'm okay. All right, guys. So the handout last time was this. All right, the one with all the colors on there. And I had 2 example problems at the bottom that I asked you to try for today.
The bonus one and
And I'm not going to collect it. It's not for grading, so you just try it. That's all you had to do was experiment, try it, see what the hell happens.
the bonus is scary.
Right. If you ever do a word problem and you end up with somebody making negative money, that's probably wrong. They go to their job and they pay money to be there. That's probably not the truth. If you get a negative side link for something, that's probably wrong. He's trying to tell you something wrong. Don't tell me that the side length of your garden is going to be negative 8 feet. Right? Yes, ma'am. Oh, that's right. Don't let me forget. So, real quick, before we do that, I forgot somebody gave me a couple questions earlier.
It's S.
It's a 5. Let's do this. So, there's a big difference between these 2 problems, and it kind of throws people off every now and again. This problem, what would you do? This problem here. Yeah, because you all see that that's in the wrong place? Because all your x's are right there. It's your numbers that aren't together yet. So you want to get your numbers together. So if you add 5, you get 17. Now on this problem, are the numbers the problem? No, they're all fine. All your numbers are right there, but your variables are on both sides. So which variables in the wrong? Which set of variables in the wrong place? The 11x's are in the wrong place. So subtract 11x. What's 12x minus 11x? Beautiful, 1x.
Negative 5.
No. That's it. So this problem you guys are really used to now. You move that one number out of the way, you're done. You got x by itself. Here, it's not the numbers that are the problem. The x's are on both sides, so you move the x's over. The same way. All right, cool. Second question. Weird sound. This one here. Right? Yep. So on this problem, the most common mistake I get is somebody does this. Now, what are they thinking? Why is that a mistake?
They will get negative.
They're focusing way too much on the fact that it's negative 6, so they add 6. But I always write the same note and say addition cannot cancel multiplication. You can never cancel multiplication by adding something. Because that's what's going on here, right? That's multiplication. So my W is not alone because it's being multiplied by this. So how do I get rid of this? You divide by that. You always do the opposite operation with the thing that you don't want. So the thing I don't want is multiplying my poor little variable. I'm going to divide by that thing. And of course, if I do it there, got to do it there, right? Good. So that negative 6 goes away. W equals negative 4. I love it. Because 24 divided by 6 is 4. 24 divided by negative 6 must be negative 4.
So you take out the 0 and then 6, maybe 4, negative 4.
Take out the
6.
You divide by the negative 6.
Be 6. That'd be negative 4.
Negative 4, exactly.
W equals negative 4.
Yeah, and if you want to check it, you throw in the negative 4. Negative 6 times negative 4 is
24.
Positive 24. Check. It works. Is that cool? Okay.
Awesome.
I like it. Not a word you hear too often, but I like it when it comes up. Okay. So now let's get back into the word problem stuff.
Cool.
That is definitely not a word I hear too often in reference to word problems. I am desperately hoping it's really not easy to figure out a way to give you the setup without it looking very long? Yes. Yeah, sure. Does anybody else need one of those? You need one?
Yeah.
Anybody else need one of those?
Yeah.
Am I going to have one?
Yeah.
All right. Excuse me? You're going on the list of my head. All right. So the word problems. And the biggest mistake people make with word problems, come to find out, is they try to get to the equation too quickly. The people that skip the first step. The first step is writing in English what's involved. So it's beautiful. The first step has nothing to do with math. So let that be. You want to look through, you want to scan through the problem and just see who's involved. So that first problem we did the other day, we looked at it real quick. Actually, did we look at these? No. Okay, let's look at these examples first. So a certain triangle has a perimeter of 28 feet. The largest side is 10 times as large as the shortest. And the middle side is 2 more than twice the shortest. You with me? So which one does everybody else depend on? You see what I mean when I say that? Which side do the other 2 sides get built off of?
The 2 times.
Yeah, the largest side is 10 times the shortest. The middle side is 2 more than twice the shortest.
Right.
So there's one side that the other 2 build off of. The shortest. So for example, real quick, if I knew that the shortest, let's say the shortest was 5 feet. Right, and I could do this any damn time I want to. It has nothing to do with the actual working out of the problem, but since I don't know the side lengths, I can just make them whatever I want to for a second. They probably won't be the answer. I don't think that, yeah, good. It's not the answer. They probably won't be the answer, but I can just do it just to see what the hell's going on here. What's the largest side if the shortest is 5 feet?
20.
So 5 times
50.
Yeah, what's it say? The largest is 10 times the shortest.
5 times 10.
So if I call the shortest 5, the largest would be 10 times that.
Maybe.
Kick ass. And right there, I know this is not the right answer because the perimeter is only supposed to be 28 feet. And I've already got one side that's 50. Now, please don't get me wrong. I am not saying that the way to solve this is to guess an answer and get it. Keep guessing until you get it. You could do that, but do not do that. Right? And real quick, just finish that. What would the middle side be if the shortest was 5?
Be 7.
2 by 5.
Yeah. The middle side is 2 more than
5.
twice the shortest.
Right.
Is that cool? It's 2 more than twice the shortest. So what's that?
4.
10, 12.
What do? You add first or multiply first?
Multiply.
Multiply. 2 times 5?
10.
10 plus 2?
12.
12. I like it. So real quick, I want you to realize this. What is the perimeter then of that triangle? That side, that side, that side. What would the perimeter be? It would be...
67.
Exactly. You just add up all the sides. Is that cool? You guys kind of with me? Now I really want you with me here because I have a problem where I don't know any of the sides, but I know how they all relate. So just to kind of get a feel for the problem, I can give a value to one of the sides and then see what the other ones would be. Just to see what the hell's going on. If the problem would have said the perimeter was 67 feet, right? 62 plus 5? If the problem would have said the perimeter was 67 feet, that would actually be my answer. I'd be done. That would be my answer. But it doesn't say that. Shit.
Do you just add them?
So what I do is, now, yeah, because it's the perimeter of this. So if I take the shortest side plus the largest side plus the middle side,
You add them?
that would give me the perimeter around, right?
Yeah.
The perimeter is just this, add all the sides. Okay, cool. Yes, ma'am.
I get that. Then there's one that says X feet.
Yes, it has to. Because where the hell did it get 5 feet from?
Is that your X feet? Or
Yeah,
is
he
that-
made that.
Where did it get 5 feet from? I just made it up.
Okay.
Now, I want you to really pay attention. I made it up because I can, but it has nothing to do necessarily with the answer here. I don't know what the real side length is yet. Anytime I don't know something and I want to actually solve for it, what do I call the thing that I don't know? X. That's what algebra does for us. So I don't have blank spaces somewhere trying to capture the unknown thing.
So can you do another example with the X sheet?
Well, I'm going to. This is actually all side work. This is nothing you ever have to do yourself, but it's just to get a feel for how things are working in this problem. But we've identified that this guy, in a way, is the most important side. Are you with me? Because I have to know that guy first before I know the other two. Now, when you read that, can you see why? This is actually one of the most important things about word problems is, can you figure out which one is just x? And then the other ones are going to be 2x or 7x plus 8 or whatever. They're all going to be related to that. It's because the largest is something to do with the shortest, and the middle is something to do with the shortest. So I have to know what the hell the shortest is first. But what is the shortest side? I don't know what the hell it is. I'm going to call it x. Just so I have something sitting there to work with. That's all that stupid thing does. Did I have to call it x? I could have called it m. I could have called it p. I could have called it your favorite Russian letter. I could have called it freaking smiley face. All that matters is I have a symbol here to use. And x is just the one that we use the most. X marks the spot, right? So what about the largest? What would it be now?
Equal.
How does the largest relate to the shortest? What is it in words? The largest is 10 times as large as the shortest. And now that I've called the shortest x, the largest is 10 times that. So the largest must be 10x. Whatever the shortest is, the largest one is 10 times that. So if the shortest was 5, what would this be?
10.
10 times 5?
100.
10 times 5?
50.
50. If the shortest was 3, this would be 30, and so forth. You guys with me? So when we write expressions like this, we're capturing a general idea, a general form. The minute I know one, it's like dominoes. I suddenly know all of them. That's why solving for x kicks so much ass. Once I know x, I go and bam, I know them all. I just got to plug that value in, right? What about the middle side? It's 2 more than twice the shortest.
It's 12.
2x plus.
I like it. So you can say 2 plus 2x, or 2 more than twice the shortest. Well, we had a problem just like that on the first test. I don't know if you remember that. Just by itself, I said 7 less than twice a number, or something like that. 2x minus 7. So 2 more than twice something. That's 2x plus 2. How are we doing so far? Yes, sir.
Since you're finding the perimeter, does it matter what order you go on? Does it have to be shortest, largest to middle? Can it be largest, middle, shortest? What do you
It doesn't matter how I list these.
Right.
But guys, the most important part of a word problem is figuring out who has to be just x. That I can't screw with. I can't call this one 10x and this, right? The shortest has to be x. Do you understand? Don't accept that. Don't say, yeah, Jeff said it so, because it is. But why the hell does that make sense? Does it make sense? Why I've got to call the shortest x to get things started?
Because everything depends on which.
Everything else depends on the shortest one. The largest is something to do with the shortest. The middle is something to do with the shortest. So I got to start there. So I give the letter X to the one I have to start with. So if Bob makes $5 more than Fred, Fred will be X. And then Bob can be X plus 5. I can build off of that for the other dude, right? So the shortest guy is what these two get built off of. 10 times shortest, 2 more than twice the shortest. I could never write these if I didn't call him X. How are we doing so far? Yeah, sort of. Okay. It takes a little while to sink in. Some of you guys are like,
Oh, shortest, largest, shortest, shortest.
yeah.
I have a question. Okay, on the middle where you have 2x plus 2. Now, Is that what, 2 times 2 is 4 plus 2, it gets 6? Is that what that x?
If x was 2, I don't know what x is yet.
But in this equation, though, that's what it looks like.
Eventually, I'm not there yet on the board though, right? I know we got the whole worked out deal on the paper, but I'm trying to show you the background of where those things came from. So all I know at this step, all I know at this stage is that the middle one is 2 more than twice the shortest. And I desperately want you guys to realize right there, if I said I'm 2 more than twice your age, what do you have to know first? How do you figure out either one of our ages? What would you have to know first?
A year.
His age.
His age. If I am 2 more than twice his age, I've got to know his age, because then I can do that stuff I just said. I can double it and then add 2. So if this middle side is 2 more than twice the shortest, I have to know what the shortest is first before I can write that down. If the shortest was y, just to really screw this up, how would I write the middle one? It's 2 more than twice this. 2y plus 2. So that's really, I mean, the choice of letter doesn't really matter. It's just that we normally use x. We have y's and x's. That was what we normally use. You with me? But I could put whatever the hell letter I want to there. Really. It's what's called a dummy variable. It's just standing in the place of the number I don't know. So who cares what letter you really use? X is just the one we use the most often.
So
You guys, yeah.
the shortest would always be X?
No. If I had a problem, real quick, don't write this down. If I had a problem where I said the largest, the middle side is half the largest, and the shortest side is 20 less than the largest. Don't write that down, just think about this. Who do you have to know first? Who does everybody else depend on? The largest one, right? The middle side is half the largest. So if I knew what the largest one was, I know what the middle one is. And if I knew what the largest one was, I know what the shortest one is because it's 20 less than that. That's how you identify which one is just X. It's the one that's going to get everybody else going. So if I call the largest one X, what's the middle side?
10x.
No, come on now. Don't look there. Has nothing to do with that problem. The middle side is half the largest.
So what if the
It's not half a foot less.
so what if
It's
the largest
half.
what if the largest was 40 and the middle was 20?
Hold on. No, hold on. Exactly. It's half the largest. So if the largest was 20, the middle one would be 10. Half that. So when I say half of something, I'm multiplying. Half times something. Right? Okay, good. And then what would the shortest side be?
8.5.
20 days down?
No, I don't. Not a specific value. Shortest side is 20 less than the largest. What's the largest one?
15x.
The largest one is X. What's 20 less than that?
2x.
X, negative 20.
Yeah.
X minus 20.
In fact, real quick, this is what people don't see sometimes. Even before I write it down. And it's not a bad idea really what you were doing earlier, but I want to make sure you're doing it for the right reason. If the largest side was, let's say 45. If the largest side was 45, what would the shortest side be if it's 20 less than that?
25.
You guys agree? If the largest side was 45, and this is 20 less than that, how big would it be?
25.
25. What did you do? You took 45 minus
20.
20.
Good.
Where did that 45 come from?
The largest.
Largest. What is the largest?
X.
So you don't want to put a 45 there, you want to put a freaking X there because you don't know what the hell it is. But you do the same thing. If the largest was 60, the shortest side would be 40. 20 less than 60. So 60 minus 20. So whatever the largest is, the shortest side is that minus 20. So it'll be X minus 20. 20 less than X. Less than is that evil, most evil word. Phrase, really, right? It's the one that turns the things around. Okay, how are we doing so far? But I wanted to set this up just to really hit home how I got these and to show you that it's just not always going to be the shortest side. In this case, it was the largest because the other two depend on it. So you got to give whoever that everybody else depends on, you got to start him off call him something, and then everybody else can be called something else too. They can all build off of that. So this is like a math name for this, a math name for this, and a math name for this. So you try to give them all math names according to their relationships. Yes, sir?
Alright, so you know it's 28 feet, and you got 67 feet out of 5. Are you just plug in numbers lower than that?
I always just plug in something in for the unknown, just to see what the other guys would be.
Oh, okay.
And you can actually see how where 10x come from, put an x in place of 5. Where'd this come from? Put an x in place of 5.
Yeah, no, I was saying, you know how you got 67 feet?
Yes.
And the actual...
It's supposed to be 28. So I know that the shortest side can't be 5 feet. It should be
lower.
less than that.
Oh, okay.
Because my perimeter would be 67 feet if it was that long. You with me?
Yeah.
So this example, you never have to do this. I just want to show you that you could do it if you wanted to. And sometimes it helps you set up these expressions. But if the shortest was 5 feet, my perimeter is way too big. So I already know that x cannot be 5. It's got to be less than 5 for this to work at all. Yeah.
Can we do every shape? Like,
Yeah, you could do any shape you want.
like
I could
square?
say, as long as I give a picture to you, I can tell you, you know, the first side and the second side and the third side and the eighth side, and then, you know, that would be a little crazy. But so, first step, really, this is really the first step here. It's just the English. What are the parts involved? You don't care about the 2 more than, you don't care about the equal 17, you don't care about any numbers or anything, you just care about the English. What is involved? 3 sides. Call them exactly what they're called in the problem. Then you figure out step 2 is which one is going to be just x. Because that gets everything rolling. Then you name the other guys based off of that. And now we can finally bring in the idea that the perimeter is 28. Right? So if I draw myself a little picture, here's the shortest side, the largest side, and the middle side. I think I'll put it in the other place. I might as well make it look like that. Obviously, your picture does not have to be a scale. It's just to kind of ground you. That is obviously not the scale. You guys kind of with me? When you have a geometric problem, you really should draw it. So then you have a nice visual to guide you. How do I get the perimeter of this? Yeah, add them all up, right? So if I add this side to this side to this side, what should I get? I should get 28 because that's what the perimeter is supposed to be. Now, real quick, I want you to realize, can somebody help me out? If I put a 67 there, I know that if I had said 67, we actually already know what x should be. We already know what the shortest side should be.
5.
That would be 5. If it was 5, the perimeter ends up being 67. But did I say the perimeter is supposed to be 67? No. So if it's supposed to be 28, it can't be 5. I'm going to figure out what it is. So now you just solve that equation. I've got one side added to that side, added to that side. That's the perimeter. Perimeter is 28. Can you guys solve that equation?
Yeah.
What's like terms? X, 10x, 2x,
50.
good. 11, 13x. Who's in the wrong place?
The
The
x?
2's in the wrong place. The x's are cool. They're all together, right? There's only one place I see x, right there. But where do you see numbers? I see numbers on both sides.
Yeah.
So that's what I mean when I say something's in the wrong place. That 2's in the wrong place. How do you get rid of that 2? Subtract 2. Yeah.
Well, 13 times 2 is 26 plus 2
I
is
know.
28.
Again, you're guessing and check. That's all right. You know what the answer will be. Now you let the algebra show you that's the answer.
26.
26. Good, I like it. So you don't want the 13 there, right? And the 13 is currently multiplying the x. So you want to divide by it?
2.
Right? And I know all the answers are right there. It's real easy. But I just want to show you where this is going to come. So that means you can't just stop there, right? You got to go back here. What's really cool, if you do this step, you got all the answers just staring in your face. X is 2 feet. Don't forget your units. What would the largest be then? 10 times, what's x?
2,
X is 2. So 10 times 2,
31,
20 feet. 10 times 2, 20. And then x still is 2, right? So the middle foot, your middle foot. 2 times 2 plus 2, 6 feet. And to check, you can always check your answer. Perimeter is supposed to be 28. Where'd it go? There it is. So if you add these up, you do get 28. Say again? Linear feet? Yes. Okay. So I'm not going to go through example 2 the same way, but you can kind of go through example 2 and see where I got everything. I want you to try to do number 1.
Let's do it.
If you haven't already tried it,
You want to do number 5?
so try out number 1. So number 1 at the very bottom. Yep. Watch this. If you had like x plus y equals 8. I know we don't have 2 variables, just go with me for a second. If you got like x to be 2, what would y have to be? Well, with 6, right? So you think, okay, these add to 8, so I got the right answer. But maybe the answer is supposed to be 3 and 5. But the minute you get the wrong answer for one thing, the minute you get the wrong answer for one thing. This is the equation. So this equation got to be so of course this is of course that
I'm trying, but you're not letting me concentrate.
but your equation can you tell me Fred how much is Fred making?
I'm sorry. Having one of my
You have to be able to see 2 different
I got x minus 300 equals 8. That's what you got, right?
but you could set up
X minus 300
working on activity.
You got net 25, right?
Yeah.
Yeah, I think you're right. You're more learning.
What's up? Are we doing this one? So, yeah, well, this is more than just numbers problem. You've got to use algebra. There's really no other way to do it.
so I don't divide it.
You might eventually divide, but you've got to set up the equation first. So,
Oh yeah, because they tell you how much did each of them alone. So
well, that's what we're trying to figure out. All right, guys, real quick, before you get too far along, I'm not going to do the whole problem right now. I just want to make sure everybody's got it started correctly. What's your very first step?
2x.
I don't like that first step. Somebody else have it?
X. Fred is
Hold up. Your very first step Has nothing to do with algebra. Has nothing to do with math.
It's two people.
Two people. I love it. There's two people. Who are they?
Bob.
Bob, Fred.
Why is Bob always in that?
Huh?
Why is that name always in that?
Because we like it. Because if you turn it around, it's still Bob. Right? So Bob is in the water and he goes over. He's still Bob. All right. And in fact, really quick, this is not just Bob and Fred, but what about Bob and Fred? It's how much. Yeah, the money they make. This is money for Bob and Fred. You with me?
Yeah.
So your first step, and trust me, if you skip this step, you almost certainly will make a mistake. So if you think you're saving time, you're not, because I'm going to make you redo the section. You do that. You make the mistake. So you identify what your players are. Just English, Bob and Fred. Which one of them's got to be just X?
Bob.
Fred.
Oh, Fred, yeah.
Right.
Fred.
All right, I heard one Bob and a bunch of Freds. All right, so thankfully Fred is right. How do I know Fred's right?
Because he's twice as money, he doesn't say that.
Bob makes 300 less than twice Fred. So you see how Bob depends on Fred. Bob is blah with Fred. So I got to figure out I got to know what Fred is first before I can tell you what Bob is. Right? So if I call Fred X, Bob makes 300 less than twice Fred. So what's twice Fred?
2x.
2x. And what's 300 less than that?
Minus 300.
You guys with me? Yeah. If you wrote 300 minus 2x, I understand that mistake, right? But less than always turns it the other way around. 300 less than 1,000 is 1,000 minus 300. It's always the other way. And that's not math's fault, that's English's fault, right? If you write that, you're going to get negative money. So one of these poor fools is paying money to go work. I'm like, you got so much money, I got to get rid of some of his money. So we've done, step 1 was English, what's going on. Step 2, who's just X. Step 3, write the other ones out. Now I can set up the equation. What's going to tell me what the equation is? What are these things supposed to do?
Hey, can't you write that minus 300 and then times 2x?
Not times 2x.
Well,
Right.
You could, the same thing would be negative 300. Is 2x negative or positive?
Positive.
That's how you would turn it around. Those two mean the same thing.
alright.
I don't know why you'd necessarily want to write it like that.
No.
But that's the only way to turn it around. Because watch this, real quick. How do we turn 8 plus 2 around? 2 plus 8. Now was there a plus sign in front of the 8?
No.
Understood to be there, right?
Right.
So how do I turn 8 minus 2 around? Negative 2
Negative 2.
plus 8. Right? Same idea. So how do I turn this around? Negative 300 plus 2x. And again, I'm not sure. If you see it that way, it'll still work. But you have to be adding them. You can't be multiplying them. Right?
Okay.
He wishes he was a multiple of the other dude, but he's not. Okay. Yes, sir.
So the big one goes first, always.
I don't know in this case. How big is 2x?
5x.
325.
We don't know yet. Not based on where I am, right? For what I got written down, I have no idea how big 2x is. All right. So, do you guys get there or see where that come from?
Yeah.
All right. So keep going. Not all out. Just finish it out. Some of you guys are done, I know. Who's not quite done yet? Go ahead and finish it out.
You got it wrong.
Man, that's how you figure that out.
You're so ready today.
Yeah, I gotta go. Something popped up. That's wrong.
Okay, yeah. There should be an ibuprofen dispenser, I think, in every math classroom. There isn't. So I'm sorry, man. Somebody's got something, I know. Oh, no.
I only carry this once a month, you know what I mean?
All right, guys. Somebody help me out. How do you set up this equation? What is that going to look like? What's the equation going to look like?
X plus 2x negative 300 equal 1000.
Good. I like it. Let me real quick. So the problem says, if together they made, right? If together they made, and that tells me addition. I'm going to add these together. If together they made 1950, how much do they each make alone? Now I got to solve for x, and then I'll know both of them, right? The domino effect. Once I know one, it falls back to the other ones. So now this should be the easy step.
3x minus
Good. So get my like terms together.
3x.
That'd be
So different.
Add 300 to each one.
Not bad. 3x equals
2000, 220.
225.
Divided by 3.
Divide by 3.
We'll get 750.
750. You're close. Right? You just gave them, just took some money away from them. So what's that? What does that represent?
Fred.
The money that Fred makes. Right? Fred is X. So Fred makes 750. What's Bob make?
2.
I love it. Twice X, and we know that X is 750. So just plug 750 in. Twice 750 is
115,000.
1,200. 1,500 minus 300, 1,200.
1,200.
I got it right.
Does that make sense? What are they supposed to do when you add them together? What's it tell me? Together they make 1950, right? So when you add these, you get
1950.
1950. Sweet. So you know you're right. The biggest mistake I see is somebody skips all this stuff and they write this equation. They look at it and they say, all right, I see. All right, 2x minus 300 equals 1950.
That's what I do.
Uh-oh. But I knew at least one. You said it out loud. There's several people that are just sitting on it right now.
Well, I did the same thing. So.
All right. Guys. This is really important because this is the most common mistake. When you look through a word problem, you naturally focus on where the algebra is. Guys. Yo. So if I say like 5 less than 5 less than Sam. You say, oh, that's x minus 5, and then bam, just go for it. But this is only one person. And it says together they make this. You only got one dude making that. He wishes he made that by himself. He doesn't make that by himself. It's together. So you only got one dude represented in your equation. You're supposed to have both. So when you write your equation, just take a quick second and make sure you've got more than one thing showing up. You have multiple things in most of these word problems. Yeah.
I got 1,950 minus 300 because 1,250.
But not minus 300, because to get rid of the 300, you have to add 300. So you
So
should get the 22.
why adding?
Because I need to get rid of the minus 300. So how do you get this by itself? You get rid of minus 300. How do you get rid of minus 300?
Take away
You add 300.
300.
You do the opposite of what's being done.
That'd be 900.
No. Just add 300. That's how you solve that equation.
2250.
2250, yeah. All right, so try out. Oh,
So then Bob makes 750 and then the other guy.
yeah. Fred makes 750 because he was X, and then Bob makes twice that minus 300. So Bob makes 1,200.
Twice that.
All right, so try out number 2.
You know what I did? I just added them to what I got.
Don't do that.
1950.
I got to see the algebra.
know.
I gotta see.
That then I developed.
It's not bad to do that because then you know the answer's going to be, but I got to see this. Yeah. All right, guys, try number 2. Try the rectangle one, and a big suggestion is draw that rectangle and label it. It'll help you out. Don't make a triangle for that one. Thanks, sir. Your guns wouldn't fit the other way? I don't want to knock people in the face. That's awesome.
I got 50%.
But the big mistake you made, it's not twice the difference of something. It's 300 less than twice. You guys 25?
Try to find the other number.
It's going to go in there 800.
I get it.
It's going to go 850. One place you make this says double spread. Double spread. And then I have to see algebra. I have to see algebra. No. When I have to see algebra. Every single one of these problems, you could probably figure out which number it is by trying a few numbers. But that's not the point of this class. This class is algebra class. You have to show me the x. You have to show me the variables. You have to show me the equation that you get.
But I don't know. I don't see x. I don't see.
So the x is the fact that, do you know what the width is? No, I don't know yet. So when I first read the question, do you know what the width is? No. And do you know what the length is?
Yeah. No.
I don't. So that's where my x's are going to come. So the length is 4 less than 3 times the width. So if I don't know what the width is, I can call it x. And then what's 4 less than 3 times x? Can you write that as an expression? 4 less than 3 times that. Yep. It's not 300. This is 4. Look at my 3 times. See how you multiply? Well, it should be multiplied by 3. So 3 times the width is 3x. And then 4 less than that. Now, here's the funny thing. The minute you did that, where'd you put the x? You put it right there. So you're calling the width x. You couldn't even write that expression and call the width x. It's 3 times the width. You call it x. Put an x there for the width. Now you're closer because now your perimeter is equals to that number. So if you can write
an equation for the three
Yeah, but I was just saying.
Well, why I got 9 instead?
That'll be the equation.
Well, why I got 9 instead? X9.
That's one side. That's which side? This is like length is 4 less than 3 times. So you must have called it x here. And width is x. That would say that the length by itself is 32. I gotta get the perimeter all the way around. David Blank. What's 4 less than 10? What's 4 less than 10? What's 4 less than 10? What number is 4 less than 10? Yes. You did 10 minus 4. You didn't take 1 minus 2. So this would be 3x minus 4 less than 10. But that is how many sides? The length is 3 less than 4. 4 less than 7. That's 1 side. Which is just right? You did beautiful. You did beautiful. So it says 3 less than 4.
Where'd you get the 36?
You got 3 times. That is what's called that. So the width is because the minute you call this so that's your 2 sides. And actually, what is your width? We have that by itself will that's the whole you said that one side
Is 4 less than
So if I'm building a pin for this Swanson, and you say, okay, I need this much, and then one side, and then we're all dead. The Swanson's going to come like 6. I'm going to close it down, you got to go all the way around.
3 times is what? 3x, right? 3 times. Okay.
There's just one
Less
thing
than
that you're missing.
is what?
Yes.
Less than.
It's what I do, that might sound quite enough.
What sign is less?
Next time you will do it. We'll do it.
Less than is minus 4. Less than switches around. So you have 3x minus 4. Okay? And your whole area is.
Alright guys, so tell me in English, what are the players in this problem? Wait. Guys, real quick. Tell me in English, what are the players in this problem? What's involved in this problem?
Length and width.
Length and width. I love it. Length. Now, I love you guys. Most people I looked at, they just completely said, Jeff's full of crap. I'm not going to follow his suggestion. I don't need that shit. But please, dear God, like I said, you ain't saving no time if you got to redo it. So if you just write the play, the length and the width. Now, which one of these is just X?
Wait.
Why the width is just X?
Because length depends on that.
And the really funny thing is, watch. Let me write this down. 4 less than 3 times the width. Right? A lot of you guys keyed in on that phrase. Now watch. A lot of you guys that I looked at, you got this expression. Some of you had it turned around the wrong way. Well, what's 3 times the width?
3x.
Now watch. The minute you say that, guys, hey. The minute you say that, what are you saying the width is by itself?
X.
You're saying the width is X. So the width must be X because I can't write the length until I know what to put there. But a lot of people see this and they know that this is 3x minus 4. But you got to realize you just called the width x. That's how you were able to write that. You guys got it with me? So you got to have these sides. Now the next mistake. So the first level mistake I see is this. Right? And really, I want you to understand, this is saying that one side is 32. So if I have 32 feet of fence, and I want to box off this hole that goes to hell. There's a hole that goes to hell. Monsters are coming. I want to box it off. You with me? And I tell somebody I've solved this equation, guys. I solved this equation, and I say this. They're going to build the one side, and then that's it. Shit, we're out of board. And the monster's going to come up and eat us all. That's great. Right? Good job. Math could not solve the same thing. But then the next level mistake is that. That's still not quite right. And that's why I said draw the picture. So what's the width? X. Isn't there another one over there? What's the length? Isn't there another one over there? So what's this perimeter? X plus
3x minus 4.
Tell me, hey, guys, tell me. What's the perimeter of this? What's the perimeter of this?
14.
24.
What is perimeter? Yeah, hey, guys. Yeah! What the hell? What does perimeter mean? Add up all the sides. So don't say 5, don't say 12. That's shit. What's all the sides? 24, yeah. Because you got another 7 there and you got another 5 there. So the perimeter's got to go all the way around. If I write this, how far have I gone? Halfway. Again, the monster's going to get out and eat us all. Thank you very much. Right? Freaking monsters. So I have got to draw the picture so I don't forget anything. So the hole from hell, the little monster comes out, you can't go in it. So this is the perimeter. This is the perimeter in algebra speak. And of course, what is it supposed to be? 32. That's why when you have a geometric problem, when you have a picture you can draw, you draw it and label it so you don't forget anything. When you don't draw a picture and you don't write this, you get that. When you draw the picture and don't label everything, you get that. When you do everything right, you get that. And then go ahead and finish that out. Yeah.
If those is Bob and Fred, so what's we gonna do?
If it was what?
Bob and Fred.
I'm sorry. That's a totally different problem. Right? Bob and Fred might be in here because we don't like him very much. The monster's going to But Bob and Fred...
This person, that's why I did x plus 3x minus 4 equal 23.
32. I got it. But on number 1, how many people were there? On number 2, how many sides are there? There are 4 sides. Huh?
I thought those person.
No. It's the lengths of sides. Right? The width and the length? The width and the length of a... Okay. So this is the width. This is the length. Yeah. Cool. Are you guys solving that equation?
Yes, sir.
Don't say it out loud yet.
I solved it in the wrong way, but I get the same number.
So you're supposed to get 4 numbers?
Well, you get 2, but you understand that there's 2 repeated, right? But you got a length and a width. That's why I can just say a board is 2 by 4. I don't have to say it. The 2 by 4 by 4.
I put like x minus 4. I didn't put x by 1 minus 4.
Okay.
X
I don't care. And I'll speak directly to that. All right, guys.
So why you got 3x minus 4 on it twice if it's a full complete square?
Because to go all the way around the square, how far do I have to walk? I have to walk x, and then 3x plus 4, minus 4, and then x, and then 3x minus 4. Right? Just like to walk all the way around this, I got to go 7 and 5 and 7 and 5. Right? So when I say I'm going to walk the perimeter, I better walk around the whole thing, or else the bad news is just going to come in the back. And he never walks back here. Shit.
So to get the width, you have to go 3x at the bottom and 3x at the top.
Yeah. Once you get the width and the length from what they say, you just put it over there also, and you put that one over there also. You know they're the same across from it, right? We know that's how a rectangle goes. Guys. So now solve this. What's like terms?
8x.
Yeah, all my x's here. So I get 8x
Minus 8.
minus 8.
Equals 32.
All right, wait. Guys, come on. What the hell? You got to talk. Go outside, right? Okay. So what are we at? So over here we got 32. Good. So the 8's in the wrong place, right? Because all my variables are there. At 8. Good. 8x is 40. X equals 5. Oh. So what is that?
That's the 5 and 5. That's the width.
That's the width. I love
That's the
it.
width.
5 what? 5 there.
5x.
5 feet. 5 feet. And then what's the length going to be?
7.
Good.
3 times 11.
Because x is known to be 5. So now wherever you see an x, you can put 5.
15 minus 4. Okay, 15.
Minus 4.
11. That's 11 plus 11
Now,
plus 5.
there's a really good question out there. Real quick, is that cool? That's done. We figured out the dimensions of that rectangle, right? That'll make that work. Now, the really evil thing about this whole experience, guys, I'm going to purposely make a mistake, and I'm not going to be able to tell I made a mistake from the problem. Because if I set up an equation that doesn't really match what the situation is, I can get answers that work in that equation that does not mean they're the answers to the thing, because I set up the wrong equation. So if I thought if I left out, what did I leave out here? I'm not thinking I'm actually answering somebody's question. What did I leave out that's supposed to be there for this problem? Yeah, I left out the 3, right? I forgot to triple that side, right? I forgot to do the 3 times part. You with me? But let's keep going. Like, I don't even realize. I don't know I made a mistake. So x plus x minus 4 plus x plus x minus 4. Is that cool? Just going all the way around? And that would be 32. Don't write this down, by the way. Just watch. So now, like terms, 4x's minus 8 is 32. Add 8.
40.
Divide by 4. X is 10. Now tell me, just by solving that equation, what does that mean when I get here? It's really weird. My question. So tell me really specifically, what does that really mean about 10? What does that 10 do? The 10 makes this true. I love it. Right? Word. So when x is 10, this is true. But that value works in this equation. Is this the right equation? No. Right? But these sides will make 32. So if you come up here and say, okay, x is 10, what's this side going to be? 6. So this is 10, this is 6. They make 32. But of course they do. What's the equation say they're going to do? Make 32. When you solve this, you're going to get a value for x that makes that happen. But it's still going to be the wrong value because the equation is not the right one. You with me? And that's what so sucks. If you're in a job and your boss is like, tell me how many widgets we got to sell next year so that we can make this much money, and you forget one little 3 in your equation, and you tell the boss we need 750,000, and you actually need 205 million or something. Well, you're screwed. You're gone. Bye. Maybe the company's bye. I don't know. Kind of with me? So that's what so sucks, is you get an answer that makes sense for the equation you wrote, but the equation you wrote is wrong. Right? Yeah.
For this problem, could you have put x plus 3, x minus 4 times 2?
I love it. So you could have just doubled this. That's fine. If you see that, that's awesome.
Okay.
Because that's halfway, so to go all the way, I just double that. Now me, I would do this. I would say x plus 3x minus 4 equals 16. If I go halfway, take half the perimeter. But those are all little tricks. I mean, there's a bunch of things you can do to make these kind of problems quicker. But you have to be really comfortable with how everything's supposed to work. You can always go right here, and that's not that bad. Yeah.
Because it's 2 equals 2. Because
What's 4 times what is 40?
that's 5. 4. That's 5.
4 times what is 40?
5. Because
4 times 5 is
50.
20.
20.
4 times 10 is
2.
40.
40. It's 20 times 2. Like,
There's no 20 here though, right? There's no 20. It's just 4 times something is 40. Okay.
I don't know how I got 2.
I'm not sure either. Now let's look at this here. Yeah.
Where's the plus here?
Oh, there's one right on the end of this building. Yeah. Yeah.
Wait, round of what you gonna do?
Say again?
You have rounded? What do you have to do? The eyes or
That's just like the first example on there.
yeah?
So if you're talking about perimeter, I don't care what shape I give you, you just add up all the sides. So for triangle, I better give you 3 sides. And on this problem, remember I did shortest, middle, largest. So to get the equation, you're going to add those expressions.
Same thing.
Same thing. Perimeter is always adding. Area is always some kind of multiplying to cover the whole thing. Yeah.
I'm sorry, Jack. Okay, I do get that, but I can't even sew the work. I can't sew the work because it's in my
The work would
head.
look just like this.
But I don't know how to do not know how to do the work.
Okay.
Because it's in
That's
my
what
head.
you have to work on. You have to work on, and that's the 3-1 through 3-3 sections in the homework.
That means
Is learning the steps for solving
That means-
equations.
that means it's smart in your head, but sometimes I heard it's dumb. You don't sew the work, but
No. Don't look at it like that. That's why you're in this class, is to learn the algebra. So it's good you're coming in, like I told you the other day, it's good you're coming in with that ability, but now you got to learn the algebra. So you're able to do more complicated problems later. So these problems are easy enough algebra problems that they're not easy because they're easy algebra. They're easy because you can see the answer. But you got to be careful. You're trying to learn the new thing. You're trying to learn the algebra, right? It's always nice to know the answer ahead of time, which you know. But then you got to force yourself to try to learn the algebra, because the equations are not always going to be easy to tell. Yeah. What's up? Yeah, they don't want you to simplify anything. They want you to write it all
So
is this the right one?
Yeah.
Okay. All right, guys.
What page is that?
Page 36, yeah, thank you. Hello. think you won that contest. Alright, so they sort of give you their steps here, and they sort of follow my steps too. So whichever steps make more sense. But here's some that are a little bit different from what I was showing you. These problems are like one step away from that. These are like somebody reading an equation in English. Like if I saw x plus 4 equals 7, you would say x increased by 4 is 7. Kind of with me? So this is not what I would call a true word problem. A true word problem is when somebody says, Joe gets on a train leaving Wisconsin, traveling at 100 miles an hour, going due south. Oh shit, right? That kind of problem. Where you got to set up your own equation. This is almost like somebody just reading an equation, but you have to be able to translate it back. So this is a different language. The difference of a number and 7. What would that be?
6. X.
Do I know what the number is?
No.
So what are you going to call it?
X.
I love it. And you're perfectly fine to be creative and call it whatever the hell you want to. You can call it box. You can call it omega. You know what omega is? Huh? Yeah. But let's just maybe stick with x. So the difference of a number and 7?
Minus x.
X minus 7. Cool. Alright, it's not too bad, right? We've done that kind of thing before. Let's say this freaky one here. The sum of 9 and a number subtracted from 6 times the number. This is getting a little bit freaky.
Oh, no.
9 plus x. Minus
Yeah, the sum of 9 and a number. I like it. So that's 9 plus x. Now, what is that 9 plus x doing?
Subtracted.
It's subtracted from.
So that will be last, and it'll be 6 times x minus.
Yeah, this is 6x. Now, where do I put that 6x?
Before the 9.
After the 9.
So what's 2 subtracted from 8?
6.
How would you write down the problem? 8 minus 2. So something subtracted from something else. That something goes last, right? So this guy is being subtracted from
6x.
6 times the number. Now there's one little thing wrong here, believe it or not, and it's a little tiny thing, but isn't 9 plus x, that's one thing, is being subtracted from 6x? So I left off parentheses, and that'll actually change this whole problem. So I got to take 6x minus
Negative.
this whole thing. So I have to put those parentheses in there to show that that's together. Now real quick, just to show you how those are different. If I had 6x minus 9 plus x, how does that simplify?
9 plus 7x.
Careful.
7x.
Negative 9.
9.
7x minus 9, is that cool?
Yeah.
Okay. If I have instead 6x minus 9 plus x like that, why is that different? What do I have to do first?
Open the parentheses.
Yeah, multiply the negative in. So what would you get then if you multiply the negative in?
6. Negative 9. Minus x.
Do you see that? So it's different because here I was adding x and here I end up subtracting x. And the problem is, if I wrote it like this, if I wrote like that first one, I'm not subtracting 9 plus x from 6x. I'm just subtracting 9 from 6x. I'm supposed to subtract this whole thing, so it's got to be in parentheses. Now, if you make that kind of mistake, I'm not going to go crazy. That's an understandable mistake. It's really easy to forget those parentheses, but I really want you guys to see why it makes sense. They have to be there. I've got to subtract that whole thing from 6x. What do I get if I do it the right way? What's my like term?
5x.
Good. 6x minus x. So this is wrong. It should be this. Okay. That's one of the harder ones to get down, is when you need parentheses there. It's really hard sometimes to tell that you need them. What about this one? I've kind of covered it up now, but a number divided by 5 added to 3.
X divided by 5.
Good. A number
Over. X divided by 5.
divided by 5
Plus.
added to 3. Yeah, that one's nice. Compared to that last one, that's easy. Hopefully. Right? A number divided by 5 added to 3. Beautiful. You can't do that. It's not equal to anything yet, is it?
No.
So I can't solve for x. So let's do something that are actually equations. So look at number 5. See what you can do with number 5. Don't say anything.
Do we have to find x or no? Oh, solve it.
Yeah.
Okay, 3.
So how do I write that in Mathish?
Minus 4.
Good. 4 subtracted from. So x minus 4. 4 subtracted from a number equals 12. So very often they're going to say equals. They're going to say is. So of course is another word for equals. So that's where you put the equal sign. Now the difference between this problem and this problem, or anything up here, is I can't solve any of these things because they're missing equal sign. It's only when I see the equal sign now I can solve. Now I can get x by itself. So what do you do to get x by itself?
3.
Careful now, not dividing.
Yeah, 4 to multiply.
Yeah, so the opposite of minus 4 is add 4. That's what you have to think opposite of what's being done. So x equals 16. Kick x. So try number 6 real quick. Don't say anything out loud. Hold up.
Number 6.
6 plus 2x.
Equal, right?
6 plus 2x.
2x plus 6.
I like it. Either way, it doesn't matter. When you're adding, it doesn't matter which way you put it.
Only in negative.
It's only when you're subtracting you have to be real careful. But I would do that. I would always just do that 6 added to twice a number. But if you put 6 plus 2x, you're fine, because you can add whatever order you want to.
Equal.
Gives. Good. Equals.
Equal minus 14.
Negative 14. I love it. So the 6 is in the wrong place. 2x equals
20.
Minus
12.
negative 20.
Negative 2.
Dividing by 2.
Yeah, this is multiplying, so I got to divide.
X. Okay.
minus 10. Minus 10.
You guys.
Dot.
Okay.
Have you done